Alrighty, good morning everyone. Day 2 of the Quarkus fundamentals training. Hopefully everybody was able to finish the exercises of yesterday, because this is the basis what we're gonna move on to today. So for today, what are we going to do? First off, we're gonna check out where we are, see if everybody is at the same point in the exercises, and I will show in a little demo of what I've built, so you can compare your own solution. Then we're going to start to build the shop service and also securing that. Securing that shop service might be tricky. I've seen people fail with that. So if you can't get the security to work, just leave it as it is and leave it up to later, and just return a username, a test username or something. You don't have to actually implement the entire security thing to get the shop service to work, and it would be a shame to get stuck there and not move along with the other stuff. But that's the entire morning actually, so that's quite a big chunk of the day. But there's also a lot of things that will be repeated from yesterday, but we'll see how that goes. Then of course 12 o'clock again a lunch, and then in the afternoon we have a lot of small topics. First off, the health and metrics we're going to touch upon. We're going to create our own configuration. We're going to introduce fault tolerance or resilience, whatever you want to call it. And if we got time, we'll create a native image of our subservice. Creating a native image of the inventory service could be problematic if you're using, for example, Liquibase. There are some nasty things there. You could try to do it as well, but shop service should be quite well contained and easy to create a native image of. And then at the end of the day, I'll be showing what I've built for the shop service as well, so you can compare your own solution with it as well. If you have time, maybe this morning, because it's a very big chunk, you could do the bonus exercise of tracing and introduce tracing in your application. Very useful in the real world to see which parts of the application take a lot of time, which other applications being called, and maybe what they're doing in the code there. So that's really nice to see. And we'll finish at 4 again. So did everybody finish until the implement database part? Maybe people can put it in chat. So one did not finish. Are you able to finish this quite quickly, or are you stuck? Maybe you can have a little chat afterwards, and then we're gonna see how we can get you moving along for today. But first I shall show what I've done in my application, my inventory service. Then you can compare it with yours. Hopefully it's visible for everybody. Let's do it this way. No, it should be visible even on a small screen. So what I've done here in the inventory service, I've created a package structure for some infrastructure stuff, for the repository, for the entities. So I have a brand entity. I'll be using Lombok. Don't know if you're using Lombok as well, but this way I have a nice entity. I have a builder on there to create the classes easily in for example, unit test. My category is, well, quite similar and quite easy. There's an ID and a name, product, a bit longer. And I have a product repository, which is a Panache repository. And it's a repository base because I wanted to use an integer for the ID and not a long. So I needed to override that here. And I've created a by name function. And that's, I believe, for the exercise of today. I also got a resource. I got a product resource. The pricing thing you can ignore because that's for today, for the shop service. But here I got a get products. It's a get function. I've documented it with OpenAPI. So I created a API response for the result code 200. Nothing else, because there shouldn't be anything else returned. And it got a schema implementation of product DTO. And the product DTO is a simple class that can be serialized to JSON. And the product DTO has a builder as well, so I can map the things that coming out of the repository directly to JSON. You could not do this and just return the entity as well, but this is a little bit cleaner. And also I included a list price that gets the prices, and well, this is for the exercise of today as well. Any questions so far? If not, then in the infrastructure is something from metrics, but that's also for today. And what I've done is create a database schema migration in Liquibase, which has two migrations. First off, the create tables table, and then the load data. So I've copy pasted the create script and the data script of the exercises, and paste them in here, and just included that in a change set with the SQL file. So this is a very easy way to do this migration. And in my application properties, I don't have anything of interest. This also for today. I've set the Quarkus liquid-based migration at startup at true. So when the application starts, it will start to do the migration. And that's about it for what we should have done yesterday. Are there any questions? Are there any questions? Then I'll move forward to what we're going to do today. Today is building the shop service, and inside that shop service we should create a card for a specific user, and that specific user is going to be retrieved with the logged in user. We're going to mock the security provider, so we're just going to create our own token, and we're going to create a web token, or a JAWT token if you would. What that means is that the normal flow goes something like this. The user enters a username and password on a website and posts that username and password to the server. The server creates a JAWT token with a secret and returns that JAWT token. And any subsequent requests of that user will have the the JAWS token in the authorization header. So maybe you've seen that before. If you do a HTTP post, there's something called authorization and then bearer, and after that bearer is a big long string, a base 64 string of a JAWS token. Then the server checks that JAWS token that had been sent with the request. When it's successfully decrypted and verified, then it's okay. And then it sends a response back accordingly. That means that it doesn't have to check if the username and passwords are correct. Again, that's only being checked when creating the JAWS token itself. When the JAWS token is created, it will be signed with a private key that's known by the server. And then it only needs to check the signature of that encrypted part. So how does this, what does this JAWS token look like?
Jago, I have a question about that.
Yeah, sure.
Always thought that, can you switch back to the previous slide?
Yeah, sure.
I always thought that the idea was that the JAWS token itself was verified by the client afterwards, and that you no longer need the server to do that. So that the client checks the signature based on the public key that it receives from the server.
Yeah, that's correct. But it can also be verified on the server itself. So indeed, it doesn't need to go back to the authentication server. The server here is the authentication server. It doesn't need to do that. Okay. It could do that, but it doesn't need to. So it can also verify the public key. And with that public key, it can verify the if the token is still valid or not. Correct.
Yep. Okay. Thanks.
So that means that, well, if your authentication service goes down after the user have logged in, you still could be able to use the application. So that's a nice feature of this as well.
Yeah, and also to have not a single point where you can have a bottleneck, because then you can overload your server, because it needs to check every time that signature.
Yeah, exactly. So what does a JAWS token look like? Well, it's based upon three parts. A header, a payload, and a signature. The header part is a JSON token. That's first of all. And in a JSON token is some metadata about how that JAWS token is built up. In this case, the algorithm and the type of token that's being used. That's used by the application or the server to verify the token itself. And then you have a payload, and in that payload you could have a lot of information. There are some mandatory fields or fields that's always being used. For example, the IAT or issued at, and that's a timestamp of when the token is being created, because the token is always valid for a certain amount of time. And when that time has expired, you need to renew that token with the authentication server. And all that information that's been stored in the payload will be signed into the signature. And the signature is being created by the authentication server with its private key. And you can verify that with the public key. And that means that you can't change the payload, or the client can't change the payload, because the payload also contains, for example, the groups that the user has access to. So you could say, hey, it's just a JSON token. Let's edit the token and let's change my groups. But then the signature wouldn't match, and then you'll be kicked out of the system, because then you have an invalid token. Any questions about this? If not, then this token that we're going to use in the exercise is just a token that we're going to generate on our own machine. So you have a separate Java runnable, so to say, that you can use to create a token and just post it to the server. So you have to manually do that, but you'll read all about it in the exercise itself. Then for this morning, it's the exercises for the shop service, the shop service security. Don't worry if you don't get it to work. Then you could just skip it and just return a username, or just create a query param or a path parameter that takes in a username. A little bit hacky, but well, you shouldn't be stuck at the security step. And then of course implement the shop service, and then call the product service from the shop service, because it needs to know the price of the chart, for example, of the cart. And if you have time left this morning, have a look at tracing. That's a really interesting topic. That's it for now. We have until 12 to finish up even what we have to do yesterday and these exercises. And I will see if I can help the persons that are still stuck in yesterday's exercises, because well, it all builds upon yesterday. So we should try to get you guys moving along. So what I can do is create breakout sessions and go in there, or in the chat. Maybe we'll start it out in the chat, see where we're going. So that's it for now. And I will see if we can get you guys unstuck. I was wondering if everybody had a chance to implement the security stuff. I would like to see that in the chat. Also an opportunity to see if everybody is already back from lunch. So did you get the security stuff in the shop service, or did you bypass it? So for some it seems to be a bit too much. Like I said, probably is, and well, if you can work your way around it, then that's also fine. For this afternoon, we have a lot of little topics on the agenda. I will briefly explain them, and then you have maybe 15 minutes or so to play around with it until we go to the next exercise and the next topic. So the first one is health. So health checking. So health checks are provided or are used to probe the state of the computer of the running application. So with health, you get a additional endpoint in your application that will expose if the application is running, and everything. If everything is fine, then you will get a HTTP 200. But if something went wrong, then you get a 500 or something. And this is used for example, load balancers to well, either include you in the routing of your application, or to stop you from being called. So there are different status codes for different scenarios. You could also, for example, say to the load balancer, when this HTTP code occurs, then you need to back off some traffic, for example. But it's mostly used for monitoring, for example, in load balancers or in other applications, to see if your application is still okay. And if you got it running, if you curl the endpoint or use the endpoint, then you will see that it reports for every different backing service the status. So if your database, for example, goes down, then your health will go down with it as well, because there's no point in calling your service if your service can't reach the database. But if you call it endpoint, you get information about what's going on. So you will see that the database, for example, is down. If you have multiple databases, you can see exactly which database is down, or any other stuff. You can create your own health checks if you want. So that will be called when the health endpoint is called, and you can do some status checking or whatever you want. And with that, bring your application down in the load balancer or in your monitoring tooling as well. So there are some different types of health checks included. So there is a readiness check that will, well, it's not called on the health endpoint, but on readiness. And that will allow you through our applications to see if your process is already running or not. This is also used in some container platforms as well to see if the application is fully started. For example, some applications will give a HTTP OK on the health endpoint because it is up and running, but it's not fully initialized yet. And that kind of stuff you can put into the readiness check. And when your application is ready, then it can accept traffic, for example. So it can be used for that as well. Then you get the liveness check. That is, well, is the application running? That's the default health endpoint, to be exact. And you have a startup check, which is kind of the same as the readiness check, but is before the liveness and the readiness check. So there is an exercise for this as well. So you can add the health extension to both the inventory service and the shop service. So it shouldn't take that long, and you can call the endpoint and see what's going on there. And there's metrics. Metrics is a little bit more. There is a difference between metrics and the health check. Primarily, the health check is used to see if the application is running or not, and maybe with readiness is already fully put it up. But then there are metrics, and metrics you can use to see how the application is responding. Is it responding fast enough? Is it having trouble throughputing enough requests, for example? That stuff you can put into metrics, and there are a lot of metrics to be enabled. Quarkus comes with Micrometer by default. You can use other providers if you would like, but this one comes out of the box. There are counters, so you can have a simple counter for example, the request. So you can count the number of requests that came in. There are histograms, or also known as distributions, and those are primarily used to measure something on average. So if you would like to measure the response size, for example, how large the response is, or the incoming payload, and then you can plot that over a given amount of time. For example, by default, it's probably 5 minutes or so. And then you can see the average response payload, for example, or the average response time not, because, well, that's therefore are the timers. But you can play around with averages or other statistics like the 59th percentile or the 99th percentile and that kind of stuff. So have a look at that. Timers are actually histograms with a little counter attached to them. So they have the same information as histograms and counters combined, and are primarily used to see how long a method call or a REST endpoint, the duration of that. Then there are gauges. Gauges are a little bit special as they are filled at the moment they are called. So if you create a gauge, then when the metrics are collected, the gauge is called and, well, is asked what's the current value of something. So what you can do is check, for example, the database of how many users there are in the system, or how many open shopping baskets there are, that kind of stuff. But if you call the database, then you might have a problem with performance because, well, the gauges are called whenever the metrics endpoint is being called. So that every time the metrics endpoint is being called, you will do a database call, and that's really not advised. So usually you put a timer in there and or a schedule thing that calls the database at a given amount of time and just caches the result. And then it will just be returned into the gauge. That will make it much faster. And by default, in the exercise, you will add a Prometheus endpoint. Then all the metrics that are collected in the application will be exposed onto a Prometheus endpoint. That is just a endpoint by default with a text-based output. You'll see that in the exercise, and I will try and show it at the end of the exercise. And then there are all the metrics information, and usually a Prometheus server scrapes that information and puts it in the database, and then you can create graphs on that, for example. And maybe I'll have a demo at the end of this exercise for you as well. So for now, it's the idea that you do the health and metrics exercises. They are both small. If you're not ready with the shop service yet, you can implement it in the inventory service, for example, and later on in the shop service. But if you already got it running, then maybe you can do it in both. And for this exercise, we have until 2 o'clock, and then is the next small piece. And if there are any questions, please shout out in the chat.
So I have a question.
Sure.
I normally do work on Spring most of the time, especially Spring Boot. So Spring Boot provide these things out of the box, especially those checks, liveness, readiness.
Yeah.
I have seen in the past, if my application is busy with the actual load, then liveness check will gonna get failed. And if it is running in Kubernetes, then Kubernetes will gonna restart the board. That Kubernetes should not be doing, because that was a genuine load, but liveness check got failed. So is Quarkus doing something different here, or it is the same request pool where the load is coming as well as the liveness and readiness checks are also coming on the same pool, request pool?
I don't know if they're on the same request pool. I hope not. That should be well. It's a little bit hard to manage the request pools of the health and readiness checks and the normal request. I haven't yet seen this behavior yet, but I haven't seen the behavior when there are too many requests overwhelming the server. So I really don't know. I'll see if I can can find it out.
Okay, thank you so much.
Yeah. So I hope everybody got their metrics and health endpoint up and running. What I would like to do is show you a little bit about the metrics. There was a additional or bonus exercise to get the Prometheus Docker container up and running and connected to your application. I've done that in my environment, but let me first show you what's going on under the hood. I don't know if everybody saw this interface. It is the dev UI of Quarkus. It was mentioned a couple of times in some of the exercises, but well, it's easy to read over that. But what it gives you is a nice overview of all the things that are running. So if you go to q/dev on your application, you can see all the things that are running in this application. You can see the liquid base that I've got here for the inventory service. It does get some data sources. There is a health and a health UI. So if I click on the health endpoint, you will see the health check coming up, for example. And there's also a way to go to the Swagger UI here. And I believe this is the first place you saw that in the exercise. So if I click on this and I get my products, for example, try it out and execute, it will load my products. If I call this a couple of times, for example. Then I have my Prometheus up and running, and Prometheus has a query language for itself. It's called PromQL. You can read all about it on the internet. But what I do here is I get the HTTP server request seconds, just how long did it take. For the inventory service, with status 200, so I'll get only the OK requests plotted here. So if I execute this, you will see how long it takes. You will see the first time I booted this application up was a little bit after we started the exercise, and it took a little bit longer to run that than it does now. That has to do with the lazy initialization of a lot of things inside the Quarkus. So the first call to the database will take a little bit longer than the additional calls later on. But here you can see how long the request took on average. And you can play around with this interface if you like. And if you would like, I can add the configuration that you will need to run this in the exercises Git repository. So I'll do that after the next exercise. And if you would like, you can also see the metrics endpoint. What's been created by Prometheus for every metric that is in this application. So you can also see there are some default things such as JVM memory usage and that kind of stuff, so that you get those things out of the box. So that's also nice. And maybe also something that not everybody saw or noticed. When you run the Quarkus application inside of the terminal window, then you get the option to do some stuff inside of the console. So if we type H, then you get a help function, and then you can see what's available for you. There's also an option to open the dev UI. So if you type D, then we'll go directly to the dev UI as well. So that's a nice feature. Also, it has a force restart, which is sometimes useful. If you do something that isn't picked up, shouldn't do that, but well, it can do that. Sometimes you can press S and then the application restarts without having to shut down Maven and boot it up again. So that's also a nice feature. Something I'll use quite some time now. Alrighty. Then the next part is the configuration. Well, Quarkus uses the small right config, and that's implementation of the MicroProfile config as well. So in this exercise, you will create your own configuration, read it out of the configuration file, and do some price manipulation with that. We'll take 25 minutes for this because it isn't a big exercise. And the next exercise will be fault tolerance, and then after that is the native image. And then we're done for today as well. So only a few chapters left. So see you around 2:30. And if there are any questions, please put them in the chat or shout at me. Alrighty, hope everybody finished the configuration part. If not, if you got stuck anywhere, please let me know in the chat. For now, we're just going to continue with the fault tolerance. It's also an add-on for Quarkus. And it basically has to do something with, you have some service, could be a local service, could be a remote service, doesn't matter. And it has a line between that, so it's calling a shop service, for example. And what happens if that line fails? So there are multiple things you could implement in fault tolerance. There are things called retries, timeouts, fallback, and a circuit breaker. I'll just go to the website because they have excellent documentation for this as well. So for a retry, you can add an annotation retries on a method, and if that method fails in some way, throws an exception, then it will be retried at the X amount of times configured here. Could be useful if you got a flaky backend server, for example, or whatever. You have timeouts. That means that if it didn't get a response in the configured amount of time, then it will throw a timeout exception, I believe. And then you can do something else with it. It throws a timeout exception. And you can handle your flow in another way, for example, or do a retry on that. So you can also combine those two annotations. More useful is a fallback. So if you have a thing that wasn't successfully called, for example, your backend service was down, you could define a fallback method, and that fallback method would return, for example, a empty list or a other response for the server to handle, or maybe go to another data source, for example. And then you got a circuit breaker. A circuit breaker is more complex. A circuit breaker is something like the electrical circuit breaker that you've got in your home. If everything is fine, then it will not trip. But if the circuit breaker trips, it will block any subsequent calls to that method. They will all get a circuit breaker is open exception. And after a configured amount of time, the circuit breaker will allow some of the requests to go through. If those requests that go through are okay, then the circuit breaker will untrip itself and will close again in the circuit breaker terms. And then you can just call the backend server again. It's quite useful. You could also define a number of calls that need to be filled, or a percentage, for example. By default, it's I believe something about 75% or so, or 50% ratio for a volume of 4. So if 2 requests out of the 4 requests fail, then it would trip. So if only 1 request fails out of the 4, nothing would happen. And that's also something that's sliding. So if you've got 2 subsequent calls that fail, then you're out of luck, and then it trips. So it's quite useful, especially in the real world where not everything is super stable, and well, especially the circuit breaker helps to prevent flooding of other servers, for example. For this, there are also some exercises. Also take about 25 minutes to implement some of the fault tolerance in there. And I've just looked up the other question that was asked before for the health endpoint. Is there a different request pool or different handler for the request to the health endpoint? I really can't find it. So I don't think there is. So if you somehow manage to flood your server with requests that can't handle any more requests, then it probably won't be able to handle your health request either. So, but that's also maybe a good sign to stop it. I don't know, maybe use case. But I can't find anything online that it is implemented. So ready until 3 o'clock with fault tolerance, and then the native image. Okay, I hope everybody got the fault tolerance pieces all together. If not, you still have some time to finish this off. And the next topic is to create a native image. Normally, Quarkus runs in the Java runtime. That means that it has some overhead of all the Java stuff that it needs to do. Java is a language that is interpreted in the beginning, and then it's compiled into bytecode that the machine executes. What you can do with Quarkus or with GraalVM is to create a native image of your application. So that native image is just an executable on your system. That means that you can run it directly without any Java. And it also means that your code isn't interpreted anymore. It's directly bytecode. So it runs a lot faster. If you got the time and finish all the other stuff, you can maybe create a native image of the shop service. Shop service is a quite easy service to create a native image from. You do need to have a GraalVM installed on your machine to make this work, and probably a native image builder within that GraalVM. But you can also create a Docker image, and the actual building of the native image is then done within Docker, and the Docker image contains all the stuff that is required. So that might be the easier route to do. So on this website and in the exercise, you will see a link on how to do that for on your system. So it creates a executable if you're on Windows, or a binary if you're on macOS or Linux, and that binary is only usable on the same system. So you can't move your executable from Windows to Linux, for example. So you have to create an image on Linux to run it on Linux. Or you can use the Docker container, because that Docker container uses Linux beneath it. So for now, for the last half hour or so, have a look at the native image. See if you can make it work on the shop service. If you're lucky, you can do it in a few commands on the command line, and try it out and play with it and see how much faster it is and what you can and cannot do with the native image. For example, you will see that the DevTools are gone and that the kind of stuff. So have a look and see you back at 3:30. Alrighty, I hope that everybody got a native image up and running. If not, you can always try later on. What I wanted to do now, because we run out of topics and about to run out of time, is to go over the solution that I've made for the exercises. Now you can compare it with yours. And at the end of the course, I will try to create a zip file of everything, including the presentation, and see that it will get to you, and then you can play around with it yourself a bit later on. So for now, I'm going to my IDE. So the inventory service I've already demonstrated. So for this time, it's the shop service. I do got a separate package for the generate token class, and that's for the authentication. This is a runnable class that will generate a token for me, and it does that with this user and with a groups, users, and admin, and something with a birthday claim in it. So you can see that you can add additional information in the draw token. So what I've done more is I have a inventory client, and this is the REST client that you use to call the inventory service. and it is used to get the pricing of the product IDs. And the inventory price is nothing more than a big decimal that's being wrapped. Got a repository layer with a card. That card is just there for all the things that the user is shopping for. And there is a total price that is being recalculated every time the card is being fetched. And of course, there is a repository, this time without the override, just the plain old Panache repository for the card. As you can see, there is no implementation here because I'm using only the default method that Panache is giving me. And I've created a product reference because, well, the products live in the product service or in the inventory service. And I don't want to have a technical ID or a actual reference to that database because it's also living in a different database schema, or maybe in a different database at all. So we need to have a reference to a specific product. So the product reference ID itself is the identifier that's being used in the shop service. And the product ID is the ID of the product from the inventory service. And this way I can connect those two. And of course it has a chart attached to it. And the product references are also stored in the database. And again, it's just a Panache repository. There is a chart service. So moving a little bit up in the layers, we have injected the card repository, the product reference, and the inventory client. And if I do a get cards, it will try and fetch the card for the owner. And the owner is the user that's being fetched by the authentication. If it can't find a card, it will create a card for this owner, and this owner can update the card as well. So it gets a card, and then it updates the product references, and it will update the price. The price is also something nice. It will call the inventory service, or it will actually call the other service and get the pricing. And it has some resilience to it. So if that one fails, it will retry again. Then we have the REST resource, where you can see we are injecting the JSON web token or the JAL token. And with this JAL token, we can get the username, for example. So we can get that from the security context. That's something you can inject in the parameters as well. If it doesn't know it, it will return anonymous. And if you screw around with the principal and the JSON web token, well, it will blow up as well. That's not a good sign. And otherwise, it will return the name of the user principal. We can just try that out with the whoami method. And that's about it for the card service. There is some configuration, primary and public key. Those are used to generate or sign the JAL token. And for the configuration, there isn't much to it. There is a little bit of configuration for the database. In testing, we're using H2 database. This is used for the MicroProfile JOT implementation. And this is where the product service is running. And you can see this is a little bit of funky properties. This is the MicroProfile spec. Actually, the MP stands for MicroProfile. So MicroProfile REST/URL for the inventory service is this URL. And I've set up tracing for Jaeger, and it will try to post everything to the tracing service, and I'll show that in a bit. And I've also added tracing for the database. So if everything works as it should, then we should see the actual calls to the database, the queries in the tracing as well. Alrighty. Now the fun part is I've just created a native image of the shop service. So that was going on in the background a while ago. It actually takes a long time to create that, but eventually within 2 minutes I got a native image, and I've started that native image. So I'm not running Java here, and as you can see, the shop service has started within a few milliseconds, and it's actually running. So if I go to the Swagger URL, then this is the Swagger URL from the native image, and I can log into the application with this job token that I've got here. So in Swagger there's an authorize button where you can add that. So if I do a who am I now, then we'll see that I am Joe at Quarkus IO. That's exactly what I've put in the job token. And that means also that I can do stuff like get my card. I have card ID 1 because, well, it's the first thing that's been created in the database, and I have nothing in my card, so it's a total price of 0. And now it's fun to see if I can get the Jago up and running. And if you had any questions about any topics, please put them in the chat, and we'll see if I can answer them. Just looking for the URL for Jago. It's always fun to run stuff which you don't normally do. Yeah, found it. I've run a Docker container that has Jago in it, and it has a lot of ports in it because it sends the tracing information over UDP. So there are 2 UDP ports being used, or even 3 UDP ports, and there are some HTTP ports. And this is the port for which the UI runs on. So if I do a search for traces of the shop service, then my most recent shop service, for example, the My Card, if I click on that, I can see what it tries to do. So there are 2 calls in for Postgres to do for My Card. Both were quite fast, so 1 and 2 milliseconds, so that's quite fast. If it would actually been called the other service, you would see that other servers show up here as well. But we do not see that now because there was no need to get to the inventory service because there's nothing in My Card yet. But you can play around with this yourself if you got the tracing up and running. And that's about it for the shopping service and the stuff that's been added in the last day. So I don't see any questions anymore in the chat. If you do got some questions left, please ask them. You can also find me on Twitter. My handle is Jago Vreede in Twitter, so you can ask any questions later on as well if you need to. And I'll be here until 4. You can finish your exercises, or well, maybe we'll see you in the next training. For now, see you later.